And we're live with JavaScript Air. Hello, everyone. My name is Kenzie Dodds, and I'm your host for this JavaScript broadcast podcast that we love so much called JavaScript Air. This is episode 038, and today we're going to be talking about typed JavaScript with TypeScript and Flow, two of the most popular type checkers in the JavaScript world. So I'm really excited about it because we have the original creators of these projects on the show today, and I'll introduce them to you in a brief moment. But yeah, today's show is going to be awesome. I definitely want to give a shout out to our sponsors that enable transcripting and the newsletter. So Egghead.io is the show's premier sponsor, and they have a huge library of bite-sized web development training videos. Check them out for content on JavaScript, Angular, React, Node, and more. Egghead.io is also the host of 2 free Redux courses from Dan Abramoff. Find them at egghead.io/redux. And Front-End Masters is a recorded, expert-led workshop on with courses on advanced JavaScript, asynchronous, and functional JS, as well as lots of other great courses on front-end topics. Check them out at frontendmasters.com. And Track.js reports bugs in your JavaScript before customers notice them, and with their telemetry timeline, you'll have the context to actually fix them. Check them out and start tracking JavaScript errors today at trackjs.com. And actually, I just want to give a quick shout out to all 3 of those sponsors. All 3 of them have been with the show since the very beginning, almost a year ago, like 9 months ago. And so I'm just super, super grateful for their support. They've been awesome. So thank you, Egghead, Front-End Masters, and Track.js. Sweet. And then WebStorm is a powerful JavaScript IDE working with Angular, React, or Node. And then you don't want to miss its super intelligent coding assistance. Use the discount code JavaScriptAir at checkout at jetbrains.com/webstorm to get 20% off your WebStorm personal subscription. And finally, Trading Technologies is looking for passionate and inventive full-stack JavaScript developers who want to work on cutting-edge solutions in a collaborative and challenging environment. Go help them build the top choice platform for derivative traders. All right, sweet. So also, fun thing about this recent change with Hangouts, I totally forgot to mention. So like 2 weeks ago, I said, hey, like this show might end because Hangouts on Air is being canceled, and like sadness and tears everywhere. Turns out that actually Hangouts on Air is just being moved from Google Plus to YouTube Live. And so like all the normal functionality, everything is exactly the same. In fact, we're using YouTube Live for this show. So one actually kind of cool thing about this is because it's on YouTube, there's now a chat, and several of you watching live right now are enjoying that chat feature right now. There is a code of conduct, and if we have trouble in the chat, then you will be blocked. So please adhere to the code of conduct. You can find it at jsair.io/coc, or just like find code of conduct on JavaScript Air's GitHub. That's where that goes to. But yeah, please adhere to that, and we will all have a fun time. Hopefully, we can keep the chat going. But I am still going to use Twitter for the live questions for those of you watching live, just because that's a little bit easier for me to manage. I've got a workflow for that already, so that I don't miss out on questions. So if you do have a question for the guests that we'll ask at the end of the show, then use Twitter with the hashtag JSAirQuestion. And also, this is a weekly show that we just totally love, and so make sure that you tune in next week, same time, same place, the normal time, for our show on Node.js and community. It's going to be a great show, and I hope that you enjoy it. And then, as always, follow us on Facebook, Twitter, and Google Plus to keep up with the latest. Although Google Plus is not my favorite thing anymore because they totally killed Hangouts, and that makes me sad. So I'm just joking. All right, sweet. So let's introduce people. First, for our panel, we have Brian Lesdorf.
Hey, how's it going?
And again, my name is Kent C. Dodds. For our guest today, super excited, we have Anders Hellsberg.
Hey, guys.
And Jeff Morrison.
Hey, how's it going?
Thank you both for coming. So let's go ahead and just get an intro to the people that we're chatting with today. Anders, do you want to go first?
Sure. So I'm Anders Hellsberg. I'm a technical fellow in the Cloud and Enterprise group at Microsoft, and I work on development tools. And I've been working on development tools for probably 35 years. I worked on Turbo Pascal was my first product, and then I worked on Delphi, and then I came to Microsoft, and I was the architect of C#, and I still dabble in that. And then I've been working on the TypeScript project for the last 5 years or so.
Cool, cool. Thank you so much for all your work. Yeah, literally tens, hundreds of thousands of developers are grateful. So awesome. And Jeff?
Hi, I'm Jeff. I work on the product infrastructure group at Facebook. We do sort of infrastructure related to development tools as well as product development at Facebook. Specifically for the past several years at Facebook, I've been working on JavaScript tooling, so anything from our compilation infrastructure to I now work on Flow full-time. I also sit on TC39 as well and work closely with TC39. Yeah, that's me.
Thank you so much for joining us today. So, like I said before we started the show, this should hopefully be like the hallway track of a conference, and we're going to chat about types in JavaScript. So you're kind of subject matter experts. I think I always like to start with a good baseline, so everybody knows what we're talking about, and that we're all like talking about the same thing. And so let's first talk about what are types, and I kind of want to go deep. Like, you know, did types exist when we were still doing punch cards in the computer and stuff? Like, when did types become relevant, and why do we have them? So anybody feel comfortable taking that on?
Well, I can say something at least, and then maybe Jeff could jump in. Well, I mean, types have always been around, and types are even around in JavaScript. It's just they're not manifest in the program that you're writing. But at runtime, things have types, right? I mean, you have numbers, and you have strings, and you have booleans, and objects, and so forth. But one of the things that distinguishes statically typed languages from dynamically typed languages is whether or not you have the ability to reason about the types before you run your program, and whether you have tools to do that reasoning. And that's really what you know, JavaScript doesn't have. You know, you find the errors, and other than syntax errors, you know, that are reported by your JavaScript VM, you don't find the errors until you run the program, and nothing attempts to reason about the validity of the program before you hit the problem, so to speak. And of course, we know from statically typed languages that it's much better to find the bug before the space shuttle flies than whilst it's flying, right? I mean, so if you can do that, then you know you can be presumably more productive.
Yeah, I would add also, you know, that's a great sort of summary of types. You also have this utility of types, especially the history of types, where they actually go into making a program run historically, right? So before, you know, until recently, relatively recently at least, we have these higher level languages now that can sort of do these dynamic runtime checks, and it doesn't actually, you can still have a performant language that way, but originally, you know, you had to compile these languages down. That's where static types typically come from. Is at the low level, you need to understand what these types are so you can run your program. So yeah, some aspects of the type origins of types there kind of come from just like raw need for running the program in the early days of programming languages.
Yeah, I'd add also that. Now that I think about it more, you know, types are great for checking programs, but they're also great for aiding you in constructing and maintaining programs. For example, if you think about refactoring, which is something that, you know, Java and C# and C++ has had for, you know, as tool features for a long time. You come to realize that unless you have types to guide your refactorings, they can become very dangerous. Like if you're, say, renaming some identifier property called name, there might be many different objects that all have a property called name, but the one you want to rename is the property of this type or of this family of objects. And you, in order to reason about that, you need to know something statically about how all these types relate. And that's why types can help you do things that otherwise you might in a 20 or 100,000 line program you could spend an entire day changing the name of one identifier, and you still don't know if you got it right.
You have to kind of augment that with unit tests, and even then you're still not 100% sure.
But
even if
unit tests don't know if they don't tell you which parts you didn't test, right?
No, exactly. I think we had a couple weeks ago we had a show about typed functional programming in JavaScript. So this is kind of related. If people watching now, they'd probably be interested in that as well. But I believe in that show, someone mentioned that like types appear to get in the way when you're as you're writing the code, but they totally make all of that worth it when you go to refactor or maintain the code.
Yeah, this is an interesting sort of debate you run into. I've sort of noticed sort of two categories of discussion that goes on over the years while sort of working in this area of JavaScript. You have the sort of category of programmers who are coming from these statically typed languages, Java and C++ and so on. And they're coming to JavaScript and they love their type system because when they get to JavaScript, they sort of make all these errors that you basically couldn't make before. And they miss that sort of safety. But then you have this other category of developers that are coming from JavaScript completely untyped. And when some of those developers, when they hear type system, they think Java and C++, and they think, oh, that's just going to get in my way. Sometimes I want to change something over here, and it's going to break some stuff over here, but it's because I want to see how this works. I just want to see how this works before I commit to fixing everything downstream first. And in a strongly typed language, that's not very easy. Typically, you have to go change all your downstream just to see if the local change even worked. So one thing that's really cool about sort of the direction that typed JavaScript is going with both Flow and TypeScript is that you have the ability to kind of go in and you have this type checker that can inform you when you've made these breaking changes, but you can also still make those breaking changes and expect the code to run. Compiling isn't a precursor to running. So I think that's pretty cool.
So I had just a basic question on the use. Well, maybe before we go into that, maybe we could just talk about the differences between TypeScript and Flow, just to give people an idea of where they should, what problems each respectively solves. Go for Flow first.
Sure. Yeah. So Flow, basically, Flow sort of tackles the problem at a different architecture than TypeScript, I think. So Flow is basically, it's not a compiler, it's a static analyzer, and its purpose really is to sort of read and understand code at a deep level and just give feedback based on the code and understanding that it's pulled out. So in the process of doing that, we can actually trace data flow through the entire program as a series of constraints. So for the most part, it really is kind of a difference in tool set and general philosophy. So when the question pops up, which should I use, TypeScript or Flow, usually it's which philosophy sort of aligns more with what you're going for. I don't know if that helps.
Certainly, and yeah, I'm curious about the TypeScript side, just knowing that it's a superset and what that can do for you.
Well, they're both supersets. In that sense, we have had, there are different philosophies. I would say that, one of the things that guided us with TypeScript was that we knew even from day one that this was about tooling. This was not about creating a new language that's different from JavaScript. This was about augmenting JavaScript and helping bring to JavaScript the pieces that are missing. I think we also knew up front that this had to be an open source community and an open source project, and we knew up front that we wanted to bootstrap and self-host, and we have built TypeScript in TypeScript. And then we have also built a tool or an IDE called Visual Studio Code, all in TypeScript. And these tools all run anywhere that JavaScript runs, including in your browser. you can host a TypeScript compiler anywhere that you want, and we see people doing that, you know, hosting it in web pages, you know, or in teaching aids, in you know, products like SharePoint or Office or you know, so this was very much about not just you know, building a type checker for JavaScript, but about building value for the community at large. I think there are some differences between how Flow type checks and how TypeScript type checks. I'm sure we'll get into that. You know, and we have different viewpoints on you know, how the thing that's funny about types and about a type inference and and advanced type systems is that in a sense, you know, the world's most intelligent type checker will simply infer a set of types for your program that make it correct and not tell you any errors, right? So this notion that you can type check something without having any annotations anywhere is you know, at some point you got to say something about, or put down some fence posts about, you know, no, this thing I'm gonna here assert has the following type, and now please check that is true elsewhere in the program. And so sometimes there's debate about, you know, non-local type inference. Should we infer from call sites, you know, what the type of a parameter is, for example? And there's a bunch of debate in the functional communities about whether that's good or bad. And we have one viewpoint, and Flow has a different one, you know. But there are pros and cons to both.
Right. Just really quick, I just wanted to throw in there, you mentioned type inference, and before I forget, I'm curious how far that could go. I know Scala has a lot of issues with their type system because they've got you know, they try to do inference with subtyping and that. But I'm curious with JavaScript, especially with, you know.
I mean, I think that the one big difference between pretty much all of the languages that are mainstream and TypeScript, for example, is that TypeScript has a structural type system, not a nominal, not a class-based type system. And that changes a lot of things. You know, in a sense, it's formalized duck typing. You know, you can say here's an interface or an object type with two properties, foo and bar, and anything that has a foo and a bar satisfies that interface. And you don't have to first up front declare that it satisfies that interface. It just does structurally, and that changes profoundly how a type checker works, and it makes it a lot less intrusive. I mean, you often find in C# and Java that there's a lot of ceremony that you have to do up front, and if you didn't do it up front, then certain downstream things don't work. Like, here's this class that didn't say that it implements this interface, and even though it kind of does, I can't like make it do it other than by writing an adapter and a forwarder and a thiser and a thater, and do you know what I mean? And very quickly you get a lot of complexity, and so I think structural is one key difference, and I think type inference it's really the thing that powers all of it. Without type inference, this wouldn't work at all. And both Flow and TypeScript rely heavily on type inference as the thing that actually makes the medicine go down. You know. I think without it just wouldn't look like JavaScript anymore at all, and it would be a painful place to be.
Yeah, I mean, one way that I like to describe inference is when you infer a type, you're asking the system to understand what you're doing for you, and when you write a type annotation, you're expressing. So it's really a difference sort of between, do you want to express what your expectations are, or do you want the system to to infer, to understand, to look in and understand the system? And so, you know, when you think about annotations versus inference in that sense, you get sort of a different perspective on when inference is useful and when annotations are useful.
And just carrying that extra meta information around for your type, is there any way, you know, I often run into issues where, you know, I'm porting something from like a Haskell type system where, you know, you can tell it what interface to use and it'll just kind of pluck it out of the ambient environment. And with JavaScript, that extra information is not really available at the the value level. And I guess that just hints at how far do you think you can take the typing? Like, are we going to be able to do like type hole driven development eventually, or do you think we'll be able to have higher ranked kinds? Like, what is the ultimate type system we're shooting for?
There's some limitations you get. Like, I think, so both type systems, as far as I understand right now, definitely Flow, and I'm pretty sure TypeScript as well, correct me if I'm wrong, Anders, are exclusively, like, they don't deal in the runtime. So they're dealing statically entirely.
Yes.
When you start dealing with these, like, higher kind of types and a lot of these really advanced type system features, you start needing the type system to actually feed into the runtime as well. And I think, I don't know, like,
well,
we're sort of.
Well, so when I think of high kind of types, I typically think of, can you have type parameters that take type arguments? That's higher kind of types, and it's sort of like the ability to construct monadic things. That here's this pattern, but the pattern itself is further parameterized, and how many meta levels can you go out? It's hard to reason about. It's hard to construct type systems that do this. We have a little bit of higher kindedness, but not a whole lot. And honestly, I think it's just sort of a popular thing to talk about. But in real world programming, it doesn't show up all that much. If it did, we would have heard more about it. I think. I want to go back to one other thing you mentioned, by the way, about how far do we think we can go. One of the things that we knew also from the onset of designing TypeScript was that we were never going to, the entire world is never going to be TypeScript. So we have to coexist, and we have to be able to leverage all of the existing efforts that are out there, or not we, but our users have to be able to meaningfully use other frameworks that were not written in TypeScript. And that's why we invented these things called declaration files, which you can sort of think of as the equivalent of header files, if you will, or the ability to, after the fact, write down the type information for an existing framework, and then have the compiler slurp that up, and all of a sudden know a bunch about, what jQuery does, or what Lodash does, or React, or Angular, or what have you. So we sort of have the ability to both code. If you're using a library, say like Angular 2, that's written in TypeScript, then, well, the type information basically is there already, right? But if you're using something that isn't written in TypeScript, say like React or whatever, well, then you can produce a declaration file for it and then get exactly the same experience, really, and without really knowing, without in your program, without it affecting your development experience. And we're actually in TypeScript 2.0, we're using Node as the package manager for external typings as well. So you can now, just like you can npm install React or npm install Lodash or jQuery, you can also now npm install the types for those if they don't provide them themselves.
That's cool. So how is that done? Is that just like somebody in the community publishes those types themselves? Like how do you manage that?
There's a site called shortly after we released TypeScript, someone created a type site called Definitely Typed. Boris Yankov is the original author of that, and that's sort of been the gathering ground for external type information. We're actually over 2,000 different frameworks are now covered, or 2,000 declaration files up there. And the latest stuff that we're doing in TypeScript 2.0, we will actually now auto-publish NPM packages out of the definitely typed repository. So anything you upload up there, whenever we basically listen to that GitHub site and with a hook, and then whenever things change, we auto-publish NPM packages. or we will by the time 2.0 ships, which is shortly.
Yeah, this is a really important, I think, feature, especially for, like you said, like when you talk about types JavaScript, you have to acknowledge that JavaScript is not typed, right? These are tools, and so you have to be able to integrate with the actual JavaScript ecosystem. That's one of the powerful things of JavaScript is this huge ecosystem. So having these interface definition, repositories is huge. We've been working on this as well with Flow. It's something that we think is pretty important for being able to not just allow consumers to maintain that the utilities they're using from NPM or wherever they're using them correctly, but it's also actually really important for authors as well to be able to publish the things that they've already verified about their program, so that when consumers consume them, they can use those verifications as well. And sort of the glue code, as Anders was saying, is this like concept of a library definition. And so yeah, I think having these library editions out there and having them sort of community managed is like strictly important for the growth of type JavaScript.
Mm-hmm.
That kind of hints at how do we get? Oh, sorry, you want to?
No, go ahead, Brian. I think you're on track there.
Well, yeah, my question is just I want to pick up Flow or TypeScript today. How do I get started?
Yeah, Gavin. Well, I think the answer is pretty similar for both of us. I mean, go to TypeScriptLang.org is where I would start, and there are links to everything there. And then I would highly recommend also trying it out with Visual Studio Code if you don't already have a favorite IDE. Although I will say that we've engineered TypeScript such that it can be plugged into pretty much any IDE. Earlier you talked about WebStorm. They have TypeScript support, for example. We have plugins for Sublime, Vim, Emacs, Atom. You name it. Likely there's a plugin for your editor that supports it. And actually, technically, the thing that's interesting about it is they literally use exactly the same code that we use in VS Code. So the way VS Code gets all of its statement completion and refactoring and all of that stuff is by running an out-of-process thing called TS Server that is sort of the magic oracle that sits behind the editor and coughs up all the right answers very quickly, when you press dot, and it should, you need to know what can go here. That's the thing serving it up. And it's exactly the same thing that sits behind Sublime Text or VS Code or Emacs or whatever.
Yeah, it's basically the same story for Flow, right? It's like if you go to the website, flowtype.org there's a getting started guide there. We're a little further behind on the IDE integration. We have integration for a lot of the big IDEs. We have integration for VS Code and for Vim, Emacs, and so on. But basically, the workflow.
I'm not hearing what Jeff is saying.
Can you hear me?
I can hear you, Jeff.
Oh, okay. Good, Anders? Can you hear? I think Anders might be.
Might need a refresh.
Okay.
Go ahead, Jeff.
Okay.
We'll figure it out.
Yeah, basically, we're sort of working on editor integration right now. We have most of the APIs sort of fleshed out. We've been working closely with Nuclide to kind of get that. But yeah, I think, I know what I was about to say. Basically, the getting started workflow is, for Flow at least, you basically just create a file called flowconfig in the root of your directory, and there's a command called flow-init, basically creates it for you. And the general direction, the workflow for getting started is you do that in a directory of JavaScript files, and then as you are ready to sort of incrementally add those files into the type system, you go and you add this @flow comment to the top of those files. And so that's sort of the getting started with Flow.
So just to get the actual type definitions, though, for the libraries, like, I have an app, right, and I'm not starting from scratch, or even if I am, I still need to get type definitions for all the libraries I want to use, unless I just want to type them as object, right, yeah. Or any. So how do you recommend finding those or going? I know there's definitely typed for TypeScript, but for Flow, is there a repository yet, or like a share the community?
Yeah, there's a repository and a growing community. We call it FlowTyped. It's on GitHub. You should be able to. I think there's a link on flowtype.org. If not, I'll make sure there is one. soon. And it basically has a CLI. You can run npm install, and then you run flow typed install, and it actually we're in the process of launching this. We're sort of aiming to launch it at the end of the month more broadly. But right now you can sort of, hey Dan. Oh, that's a picture. Right now you can explicitly list the libdefs that you're looking to install, and we're hoping that by launch time we're gonna have it so that it can actually read your package.json and install the libdefs for you.
Oh, cool. That's pretty sweet. I like that. And so like, oh wait, Kent's had a question before I started blabbing.
Oh no, you're good. I just wanted to say it looks like Anders magically turned into Dan. But no, hopefully Anders will be back. It's just some problem hearing us. But yeah, welcome Dan. Good to have you here. So yeah, I did want to ask a little bit like in the same vein as like getting started and stuff, especially when you have an existing app. Like all these alt.js languages or these superset of JavaScript or whatever you have. Like obviously these are not things that will be run in the browser. I shouldn't say obviously, but yeah, these things won't be actually run in the browser. So there's some tooling that you have to put in place, some costs that you have to incur to get these benefits. And we've talked at length, I think, about the benefits of typed JavaScript. And it seems really beneficial. Like, why wouldn't you want to do this? Can we talk a little bit more about the costs associated with this, and maybe that will bring to light some of the some use cases where you might not want to use typed JavaScript. So what are some of the other costs associated with bringing types into JavaScript?
Yeah, that's a good question. So with both systems, with both TypeScript and Flow, you've got type annotations that are going to come with. That's how you sort of express these types, and that means we're sort of extending the language a little bit. And that also means that you're going to need some sort of compilation system or transpiler to pull those things out before you actually run the code. So in the case of Flow, we sort of pair with Babel to do that. So whenever you use Flow, typically you're also going to need to be using Babel as well. In the case of TypeScript, they have their own compilation unit, so that has to sort of be integrated into your build system as well. So I'd say that's sort of one downside, I guess. I think as Babel goes on, the cost of introducing Babel into your system, at least in my own experience, other people may disagree, it's sort of the cost has been driving down. So hopefully that's not too bad. I think the other cost of this is, of course, sometimes when you want to be able to statically reason about a programming language as dynamic as JavaScript.
All right, I'm back.
Is back. Can you hear us?
Yay!
Awesome.
I don't know what happened there, but
cool. We were just to bring you back up to speed. We were talking about some of the caveats of typing JavaScript.
Mm-hmm.
So we were talking about sort of the build system aspect and how it sort of introduces a build system. Whereas if you don't have, if you have like a really small project, that may not be worth it. The other thing I was going to call out was, the fact when you write typed JavaScript, you're asking, especially with statically typed JavaScript, you're asking these systems to reason about your program statically without running the code. And that does mean there are some circumstances where the system is not able to fully extract what something does. For example, it's actually really hard to come up with like good realistic examples of these. You can come up with contrived ones pretty easily, but you could set some value in some object in one function and then read it in another, and the system may have trouble determining what order those two things come in. So it may ask you to sort of rewrite it in a different way. So yeah, I mean that's definitely also another trade-off you get with these sort of static reasoning systems. Is you're sort of trading off the ability to write any code for the ability for the system to reason about it for you and help you to ensure that you're not making mistakes, even though maybe you're not.
Although the checkers are better all the time, right? I mean, so yeah.
I have a question about Flow. So as far as I understand it, like one of the benefits of Flow is that you can gradually introduce it to the existing code base. But something that I hear from people sometimes is that the problem is hard to tell if Flow actually enforces some things. So you may have some code that you think is going to be type checked, but actually Flow can determine that like this thing is that thing, and so it doesn't do the type check. So how does Flow deal with that?
Yeah, I mean, one of the most common issues that we're sort of trying to circle right now on the team is people forget to put @flow at the top of the file that they think they had @flow at the top of. Now, @flow, when you put this comment with @flow at the top of the file, you're basically explicitly opting in to type checking for that file, and the whole approach there is you can take an existing code base and sort of module by module opt in to typing one at a time as you go, at your own pace. But sometimes people either start with a brand new project and they don't have @flow at the top, or they assume that some file in their code base that is progressively typed has @flow and it doesn't. And in the case where @flow, where a particular module is not type checked in Flow, that's the only case where Flow actually assumes any. The other thing, anywhere else in typed code with Flow never actually pulls any out of nowhere. So as long as you have @flow at the top, you can be certain that Flow is type checking your code. And if anywhere that it's not, it's going to give you an error and tell you. There is actually an ESLint rule out there that somebody built that helps you remind you to put @flow at the top of new files. So that's a really useful one. I can probably link to that at the end of the show notes.
Yeah, I'd say there we have sort of a slightly point on how that works. In that, in TypeScript, if you can have JavaScript files in your project, and those we don't check, or we don't give you errors in your JavaScript files, but we'll still pick up some stuff from them, like if you have top-level function declarations or whatever, we understand there are functions there, but you obviously don't understand what types of parameters they expect. But in a TypeScript file, we will check, and we give you sort of options to have different levels of checking, and then in fact there's one option that many people use called no implicit any, and once you turn that on, then we will never implicitly infer no type. And at that point also, you know that if there are any's in your program, it is only because you put them there. And presumably you did that because you knew what you were doing. And that also means that your refactorings are going to be safe if you do refactorings. So it's sort of, the thing that's interesting about typed JavaScript is I often say that it turns typing from a switch, from being a switch, an on-off switch, into being a dial. And you can put the dial wherever you want to put it, and then the more you dial it up, there may be some extra work, but then there are also some extra guarantees that come out of it. And it's actually quite useful in a hybrid universe like JavaScript to have different dial settings for different parts of your program, particularly as you're easing into it. And that's certainly something that we see a lot of people do now, have these mixed projects where parts are TypeScript and other parts are not, because, well, we're not touching that code anyway right now, and it works, and so we're just going to put that over here and write a declaration file for it, and then, write TypeScript for the new stuff, for example.
Yeah, that's actually exactly what I was going to ask about is how do you get the most out of the type system? I know in certain languages people are trying to banish strings, right? They want everything to be in a new type wrapper. They just don't want anything typed as a string, and that really helps a lot. So when we get into like getting the most out of your type checker, is there a specific pattern or path to get to that third dial that you recommend, or?
Well, I mean, as I said, the one thing I would tell people to do there is to do the no implicit any compiler switch, because then we will literally complain everywhere that we can't figure out what the type is.
Yeah, I mean, one sort of piece of advice that we often give, and I'm along the same lines, is like, we don't have an option for no implicit any, but sometimes people will write any, and that's a temptation. It's actually, there was a really good talk on this from the name is escaping me about a year ago, about how these gradual type systems sometimes fool you into feeling safe You have this easy out, right? You can always write any. Try not to, right? Like to really try hard not to write any when you have that option. Sometimes you have to write any and get out of there. That's definitely something I would encourage people to avoid doing is writing any. And really getting to that third dial in TypeScript or Flow, we don't really have this level of dials. We sort of use inference to kind of drive to one mode in Flow. And we assume that you're opting in module by module, and as you opt in each module, you're sort of locking that module into safety. But as you go through and sort of type your program, avoiding these any's and avoiding these like types that aren't safe is probably I think the biggest thing to get the most out of these type systems.
Something that confused me when I just started looking at Flow is the difference between mixed and any. Can you explain it?
Yeah. So mixed has the any type, which is the same actually as in TypeScript, I believe. But there's also this other type called mixed. I think James Kyle's actually writing up a blog post on this that should go out soon. He did a really good job of explaining it. So I'll try to do a TLDR, and then hopefully he'll publish that soon, and we can refer to that. But basically, mixed it is in type terms. Mixed is the super type of all types. So that means anything can flow into a mixed, but nothing can ever flow out of a mixed. So if you have a variable typed as mixed, if you ever try to assign to it, that is always okay. But if you ever try to use it, say as a number or a string, that's never okay. It forces you to like prove that it's a string or a number by using type of or whatever. With the same analogy of going in and out, if you put a parameter on a function as mixed, it means you can pass anything into it. But within that function, you have to prove to Flow what kind of type it is with type of or instance of or so on.
Does TypeScript have anything similar?
Yeah, it does. It's well, the top level. If you write curly curly, that's basically the same as mixed. It is like it's the root of anything. But because I think we have a different viewpoint on whether primitives are assignable to the root type or not. The thing that's interesting too is that in TypeScript 2.0 now that where we have control flow analysis and strict nullability checking. We also have a new type called never, which is the ultimate bottom type, the type, strangely, that is assignable to everything and nothing is assignable to it. And it's this oddity of a type that pops out when the type checker proves to itself that this variable is never accessible or this function never returns, for example. And sometimes, when you have a never and you union it together with other things, you actually want it to just evaporate and go away. Because you can say, if you have the result of a function that never returns and a function that returns a string, well, that should be a string, right? Because the one that never returns, well, that never returns. So it shouldn't add any type to that union. So there are some funny types like the top types and the bottom types in both of these type systems, yeah.
So that gets to kind of the algebra of types there, and I'm curious about sum and product types. Am I able to achieve that in TypeScript?
Yes, although we call them union and intersection types, but yes. And with TypeScript 2.0, we also now support discriminated unions, where it's particularly when you're doing like functional programming with abstract data types, or sort of the JavaScript equivalent of abstract data types, where you have a tag in your object that says what kind it is, and then depending on the kind, you have different other properties in the object.
Redux.
You'll switch on the kind. Now inside each case, we'll then already know that your reference to your object now has the correct type. Or did you guys already discuss this, or
no.
But one of the things there that's interesting too is that because of the never type, we actually can do exhaustiveness checking as well, which is important in functional programming languages. You want to make sure that you covered all cases, and you want to get an error if you didn't. And we've got that pattern covered also now in TypeScript 2.0.
Yeah, talking about the discriminated types, that's something that, you know, one of the actually driving cases for us to add that was GraphQL and ultimately Redux. Both of those systems are dealing in patterns that are really well suited for that structure. It's, you know, you have this object with this kind, and you want to be able to take a union and separate them.
Yeah, or any message processing app, right? Which all microservices tend to be, right? They get a request, and there's a certain number of requests, and then each request has a different payload, and you want to sort of switch on that and then do whatever, right? I mean, and you want to check that you handled all the possible requests. So if you've written down type declarations for that, we can now cover those patterns, yeah.
One more question, just to throw in there before I'm done for the day. Let other people talk. You know, there's stuff like, you know, covariance and contravariance, and you just mentioned the summon products, which I can totally achieve. But what features should we look forward to in both these type systems that might be coming out soon? I'm just curious.
Well, the contravariance is actually. I think Flow has some of that now, right? And we've looked at it. I don't think we're going to go there. I've been there before with C# and Scala and whatever, and it's one of those where, you know, boy, it gets painful when you start dialing in contravariance, and it gets hard to reason about. And sometimes the complexity is just not worth I find, but. I mean, you know, that there are so many things that we can keep looking at, like common patterns in JavaScript, doing like promises or whatever. We're doing async programming. You know, there are like interesting patterns coming out around that. So, I think in general we you know, with TypeScript 2.0 we've gone a long way. With control flow analysis, nullability checking, discriminated unions, and types delivers as NPM packages, I would say, are some of the highlights, and we're about to ship that just in a few weeks. So.
Yeah, I mean, so as far as the variance sort of rules, we've adopted. We sort of have strict variance rules. A lot of those stem from mutability aspects of the language, right? Like, if you have an object and a property that is writable, then if you don't carefully, you know, control for variance, then it's easy to have your type system think that a property is one type, but it's actually another. So that's one of the reasons. It actually kind of goes into like a little bit of the differences in philosophy here. I think that's maybe a good example. Sort of Flow really is about sort of deeply understanding your code, and that means that it is going to enforce this level of things. And TypeScript is sort of about the tooling aspects. The other, as far as like features that, you know, we're looking forward to, like. One feature that I'm actually really excited about, we have somebody on the team working on this. Actually, TypeScript has this now, and we've sort of taken it and sort of run with it. I think it's a really cool feature. Predicate types, they allow you to say effects that happen as a result of a function. We're sort of running out of time, so I don't have a ton of time to go into this. But I'm really excited about that. We also have some other features coming up pretty quickly, exact object types that are basically they don't deal with subtyping, and that unlocks some of these issues with variance also that you run into as well. If you say that, you know, a given object type has exact, so those are two things that I'm pretty excited about.
Sweet. I love that this area is always progressing. One of the cool things about the JavaScript community is that there's just so much that can be done, and so like getting involved is, you know, like there are a lot of opportunities, and I think that's cool. So I had one other thing that I wanted to ask before we get into the several Twitter questions that we have, and that is, like, from my perspective, I have been nervous about jumping into TypeScript because for the last year and a half I've been using Babel and ESLint and just totally loving the pluggability, especially since Babel 6 came out, like the pluggability of those systems. and moving over to TypeScript, I'd have to kind of give those up in favor of TypeScript and TSLint, which means that...
No, not at all.
Oh yeah, so that's why I'm actually asking, because I wanna be corrected. So let's hear about that.
Well, I mean, so TypeScript, we've always sort of had the viewpoint that most people want us to cover end-to-end. They want to write their code, and then they want to, say, compile, or not even say compile, but have the compile happen automatically, and then they just want to run, and they don't want to think about it. That's sort of the default modus operandi of what we deliver. And so TypeScript can take you all the way from I'm writing code in my tool, it's delivering statement completion, refactorings, and whatever. It can go all the way through the type checker, and there's also an emitter that can emit, and you can down level emit to any target you want, ES5, ES3, or whatever, or just stay at ES6. Now, if you want to use Babel, for example, in that pipeline, and we have lots of users that do, then you simply tell TypeScript to emit ES6, and then you run that through Babel to get your down level. If you want to use Babel for your down leveling.
So actually, just on that though, there are some like stage features of JavaScript, the language, that like require parser changes, which, as far as I'm aware, TypeScript isn't always up to the standard that Babel is on. And so if I'm
well, I mean, if you're
like
talking about like features that are stage 2 or 3 or whatever, well, no, but none of us are really fully up to anything because they're not JavaScript features yet. So yes, there will be differences between. I mean, we may not have object spread and rest yet, but we will, obviously. Once it reaches a high enough stage, typically we say stage 4 for sure. We will be there. Some of these things are very speculative, like the binding operator, for example. And then who knows if they're going to happen, and what do you do then if they don't happen, right? So, but certainly anything that's in the standard, we absolutely do support, and we support a lot of things that are on their way into the standard.
Okay, yeah. So for me, it's that stuff, as well as because I do use some stage 2 features and really enjoy those, and it's also like the enormous community of other plugins for Babel as well as ESLint. I think maybe I've sunk myself too deep into that community to move over to TypeScript, but I'm probably not like your target user in that regard, and maybe most people aren't quite the same as me and are happy to use.
I think it all depends on the size of the project, and we're not trying to like own the world or whatever. We're simply trying to do good and trying to create something that is useful for a large number of users. And I mean, when I look at our adoption numbers and whatever, it seems like it is. I mean, certainly we've got lots and lots of usage, and more people are coming. But if you're writing something that isn't very big, or if you're working by yourself on a project and you know the entire thing you're doing, then these refactorings or whatever may not be so hard to do, and I might not need these capabilities, But if you're a team, or if you're trying to document your code, or if it's a very large code base, then the reasoning simply looks different, right? And then it may actually be worth it to invest in using a type checker.
Cool. Yeah, that's perfect. And actually a couple of the Twitter questions that kind of addresses those. So that's great. Thank you. Cool. Yeah, let's move into Twitter questions. We're definitely going to go over on our time, which we do quite often, I'm afraid. But this has been a really great conversation. I wish we could keep going. But yeah, let's jump into these Twitter questions because people are asking useful things I think we should talk about. So Jamin Ferguson, a friend of mine, asks, what sort of collaboration is happening between TypeScript and Flow? Is there any collaboration going on between these type checkers?
Jeff, you want to? Or I mean, we talk.
Yeah, we talk on occasion.
Yeah.
Yeah, I was going to say, I mean, we've sort of talked about sort of topic, like one topic that we've talked about in the past was library definitions, like whether we could standardize on those. And I think that's sort of a tricky discussion when you get into the depths of it. Part of the trickiness that goes into that discussion is like what happens when one system has one feature and the other doesn't. You know, for example, a long time like TypeScript had predicate types and we didn't. So does that mean that you can't write predicate types in declaration files, or does that mean that Flow has to like sort of consume them and do nothing with them? And if the former, does TypeScript have its own declaration and there's a universal? At which point is it better just to write the TypeScript one if you're just using TypeScript? So there's a lot of like integration points that go through libdefs that actually become not great when you really sort of think through the details of them. Otherwise, I think like we're both involved in like TC39, so there's always discussion going on in TC39 about, you know, well, TypeScript did this and it worked really well, and Flow did this and it worked really well, and that's like it sort of gets echoed between the two teams as well. So yeah, I mean, there's some collaboration going on there.
Yeah, I would echo that. Yes, TC39 is definitely something that we're all involved in. Brian Turleson, actually, who chairs the spec right now, is for Microsoft, and we're always like understanding what's going on there, and that's sort of how the core language evolves, and around the typing aspect of it, for sure, the thing that would benefit the community is to have an agreed upon declaration file format, and I actually think it's entirely possible to do it, and I'd be happy to participate in that. I mean, we already have like an enormous volume of declaration files out there, so my primary concern would be to not invalidate what the community's already done, and just make sure that all still continues to work. But I think it's possible to do it if we were to put our heads to it.
Yeah, I think that's a fantastic area of collaboration, which would really benefit the community a lot. So keep it up, doing great. So we do have, several other questions, but I think that I'm only going to get to 2 more of these. So if you all want to check out Twitter later with the hashtag JSR question, I'm sure these people would be grateful to hear answers to their questions. So another one that I wanted to ask is from Gil Christensen. When do you think adding type checks pays off the most? Big, small, medium-sized projects, all projects, or maybe just a certain type of project?
Well, I think my sort of stock answer there is the bigger the project, the bigger the payoff. You know, and as you get more and more lines of code, and then as you get more and more actors involved in a particular project, you know, there comes a point where I would almost say it's downright crazy not to use a thing like TypeScript, you know, because you know it's just you're just wasting too much productivity otherwise.
Yeah, I would echo that. I mean, I think the area of small where it doesn't necessarily pay off is the area where it doesn't actually pay off to set up all the, you know, build system,
right.
You know, all the like structure around a project that typically you need at a larger scale.
Right.
And those two things kind of go hand in hand. So if you have a good grasp on, well, I'm just going to write a quick script, maybe don't type it. But if you're going to write something that, you know, 3 or 4 people are going to be using for a long period of time or contributing to, that's where you start sort of like having that decision to make, and deciding, do I want to add more, you know, utility to this, or is it not worth it? Is it not? It's kind of just like keep it all in my head.
Totally, that makes total sense. Cool. My last question. This is another one from Jamin, but I wanted to talk about this during our chat anyway. He says, how likely is it that a future version of JavaScript will have types? And we're not talking like, you know, actually, you know, explicit type definitions. And what do you think that would look like?
Well, this is something that's been discussed many times, even in the committee, and I don't know that there's a consensus in the committee that JavaScript will get static types. You know, and that there's been some talk about maybe having the ability to at least ignore type annotations if they're present. But the issue with that is then how do you standardize a system where you can say let x : string and then s equals 5 on the next line and it's not an error. Do you know what I mean? And so it's hard to find a happy medium there, and I think trying to standardize the semantics of a type checker, you know, is it's not for the faint of heart. I mean, I will argue that you know the TypeScript type checker and the Flow type checker, no doubt, are fully as complex as the JavaScript VM implementation is. You know, and if you have to write down all of the semantics of every corner.
Yeah.
So
I was going to echo
probably
what you
easy
said.
question to answer. I think for standardization, the thing that would make the most sense actually is to find an agree upon declaration file format. That's the thing that would mostly benefit the community. Is my sense.
Yeah, I mean, this was actually one of our first sort of collaboration points between the two teams when Flow sort of first came out. It was how can we come to the committee and sort of start talking about whether this makes sense. And one of the first things we talked about was, well, just syntax, type annotation syntax, and the pushback from the committee in that, and I think they were right, and I totally agree with Andrews here. If you standardize these syntax annotations that mean nothing, it means you can never standardize what they mean, because anybody could have written them to mean anything before. So what we did end up doing at TC39 is we said, okay, after, in these certain parts of the language and the syntax of the language, we're going to basically say you can't put stuff after a colon there. So actually, if you go and you look in the ECMAScript, the JavaScript spec, you'll find this. There's actually there's a constraint as of ES6 that says, after colons after identifiers are reserved space. And that was sort of the first collaboration effort, which it's a tiny little part of the spec, but I'm pretty good. It sort of guards us both to have this exploration in this space. But it also sort of points to the fact that, both these systems are like super hot right now. We're sort of like innovating like crazy. Both of us are coming up with new features as we go, and these new things come out, and JavaScript idioms come out. And finding the right way to do this, like we have two different approaches, but it's not like one's necessarily right and the other is wrong. We're just sort of like both tackling this. And so it's very early to come along and try to like sort of set a standard on these things, as we're still like discovering what it means to add gradual and static types to the language like JavaScript. It's something that really kind of hasn't been done very well before. Nothing that I can think of. Yeah, I guess Brian. Yeah, so in terms of like getting it as a language, maybe one day, but like I can't see it in the near future. There's just too much to like. There's too much going on right now. It's not. Brendan Eich likes to say, sort of standards follow practice. I don't know if I use words exactly, but I kind of generally agree with that, right? It's like once we've sort of found what it should be, then we should standardize it. I think it's kind of too early.
Exactly.
And I appreciate tools like Flow, TypeScript, Babel for making it possible to test things out, to make something a practice before it's a standard. So it's a wonderful time to be alive as a web developer. I love it. Cool. So that's all that I have time for these Twitter questions. Let's jump into our tips and picks, and then we'll wrap things up. So I'll go ahead and go first. So first, my tip is, no matter how well you know something, keep your mind open to learn even more about it. I feel like I actually had an example in my mind when I wrote this down, but now I've forgotten it. But I think it's a good tip. I have 3 picks. First, React Rally 2016 Notes Wiki. This is a Google Doc that the community has built up for notes about the React Rally conference that happened last week, which was fantastic. So I recommend that you check it out. Yeah, really, really good talks there. And then tomorrow, Dan and Ben Alpert and I are going to be talking about React events in depth. And it'll be live. It'll be kind of similar to the show, actually, as far as just like having a conversation about something. Yeah, we're going to be talking about how the eventing system in React works. Should be really cool. And then Husky is an NPM package for shareable Git hooks. It uses package.json NPM scripts. And yeah, I normally, for all of my projects before, I've used G-hooks, which is another similar package. But I saw Husky. I haven't tried it yet, but it looks awesome, and it seems to have a couple features that G-hooks is lacking. And so I think I'm going to give that a shot. I thought I'd give it a shout out. Cool. So I'll actually read Brian's tips and picks because he had to jump off. So first for his tips, he has 2 functions should be input to output. Type systems help a lot more when you compose this way. So I think that's like, don't just have a function do side effects, like give it something, get something back. It's nice. and then stay away from object and any types. So that's a good tip. Yeah. And then we've got 2 picks from Brian. First, John Sterling at LambdaConf 2015. I think this is a talk called Type Theory and Its Meaning Explanations, and that's a YouTube video. And Chris Taylor, I think this is it's a blog post. Chris Taylor wrote a blog, Algebra and Algebraic Data Types. So check that out. All right, Dan, do you have any tips and picks for us?
Yeah, I do have one pick. I don't actually have a URL because my pick is a blog post that is not out yet, but it's going to be out like today or tomorrow. This is a blog post by Christoph Potter. So he was working like crazy on the new Jest release, the Facebook testing utility, and it's got like a massive overhaul. All the crazy features like auto mocking that people didn't really like in the open source are disabled by default now, and the UI has received a lot of improvements. So just check it out. It'll be out tomorrow. Yeah, I think it's going to be great.
Cool. I'm so looking forward to trying out Jest now. It's going to be great. Cool. Andre, do you want to, or Anders? I don't know why I called you Andre, but
no. Well, I'll just say, as a personal thing, programming has always been my passion, and I always urge people and tell people, follow your passion, go play, go write some new code or whatever. That's how you do your best work. It's like always try to be passionate about what you're doing and try to enjoy what you're doing. When it comes to tips, I mean, I think. There are a lot of people coming to JavaScript now because JavaScript is sort of the only cross-platform game in town, and a whole bunch of client apps are being written that way. And we have lots of OOP programmers flowing into the JavaScript ecosystem from, say, C# or Java or all sorts of other programming communities. And one of the things that's interesting about JavaScript is that it has great support for programming with functions and doing functional style programming. A lot of people are surprised when I tell them that the TypeScript compiler doesn't have any classes in it at all. It is all written as functions and functions within functions. And of course we have a bunch of interface declarations because that's how we declare our shapes of our objects. But a lot of things are possible to do in ways that you are not accustomed to, and not everything in the world is a class. So there's a lot you can learn from studying functional programming and even in JavaScript, and I would definitely recommend that people do that. I've learned a lot myself.
You'd get like a giant cheer from Brian if you were still here. Functional programming is his jam. Cool. Jeff?
Okay, so I guess we'll start with tips. So I think there's this sort of strategy that I've used for a while and kind of lost touch with it, and recently I've been using it again when it comes to sitting down and like working on a big project, which is like sometimes I get hung up on just trying to figure out how it should be in the correct way. Like, how do I do this correctly? And that's not a bad intuition, but sometimes when you're facing a big problem, for me, it's really useful to just take the approach of, you know what, just get it working. It doesn't have to be perfect, doesn't have to be good, just get it working. And you'll clean it up, right? Once you know that it works, then you're going to be invigorated and excited, and you're going to go make it like clean. And maybe you have to rewrite it, but whatever, now you know how it works. So this whole like just get it working mentality is something that I think is that's going to be my tip for today. Don't like leave it in a mess, but you know. Anyway, and then as far as my pick, I'm going to pick OCaml and Reason because I think that they're languages that are scary to some people, and it's something that I came to only a few years ago, and actually they're really interesting languages, and they're completely different, most likely completely different from what you've seen before if you're used to things like C and Java and C++ and so on. It sort of like expands your mind to think about things this way, and the really cool thing about OCaml and Reason is that they're these high-level languages that are designed so well that they can compile down to something low-level and run very efficiently. And so I don't know. That's just really cool to me. It's in my head prior to like exploring this space, it was always like you have high-level languages and they're slow, and you have low-level languages for efficient stuff. And OCaml is like sort of somewhere in between. It's sort of like Rust is sort of the latest incarnation of this concept too, right? So yeah, so like OCaml is one of my picks, and along with that pick, I would recommend this book. It's an online book called Real World OCaml, and it's not a textbook. It's like written in normal English, so you can just kind of you actually go read it from start to finish if you have enough time. It's not that boring, right? And so I'll add a link for that as well. It's kind of a fun learning opportunity if you haven't messed with OCaml before.
Cool. Thanks, Jeff. These have been awesome resources and tips. So I like this section of the show. I think it lots of good resources come out of this. So cool. So just gonna wrap some. Oh, Dan, sorry.
Yeah, I have one tiny peek. I forgot about it. So I just bought this book. It's called Graken Algorithms, and it's amazing. Like for people like me who don't have computer science education, it's full of pictures. It's full of like really real-world examples that are simplified. So if you were scared of data structures and algorithms, check it out.
Sweet. All right. Cool. So yeah, let's now wrap things up. So just now I totally lost myself in the doc. Okay, yeah. So we have a couple silver sponsors that we're grateful for. React.js program helps you to master the React.js ecosystem, and Sentry is cross-platform crash reporting, so check them out. As always, I appreciate your suggestions and feedback, so go to jsair.io/suggest to suggest episode, topics, and guests, or both. And jsair.io/feedback to give us some feedback on the show. Really appreciate that. And then jsair.io/email will take you to our email newsletter that we send out weekly right after the show, like the day after the show is published, with highlights and interesting information about the show. So yeah, and then we do have a show coming up next week. It's entitled Node.js and Community. So looking forward to chatting about that next week, same time, same place. And as always, follow us on Twitter, Facebook, and Google+ to keep up with the latest. And in case you missed it, we are going to continue doing the show for now. So yeah, they didn't actually cancel Hangouts on Air. They just moved it. So good stuff. All right, that's it. Thank you so much for coming on the show, Anders and Jeff. Really, really appreciate it.
No worries.
Thank you.
Mm-hmm.
This is
We'll
fun.
see you around.
Yeah.